In this video, we're going to be looking at reducing, multiplying, and dividing rational expressions. The key to doing this is knowing how to factor. So if I'm asked to reduce this rational expression here, in numerator and denominator, first of all, I need to see if they have any common factors that can be pulled out. And in this numerator, I can see that each of these numbers is a divisor. The 3 will go into it, so I can factor out a 3. And when I do that, I'm left with x squared plus, well, 12 divided by 3 is 4, and 36 divided by 3 is 12. When I look at the denominator, I can see that they have an x term in common, so I can factor out an x. And when I factor out that x, I'm left with x squared minus 12x plus 20. Now, if I look at this, that's a trinomial beginning with x squared, and so I can try and use the trick to find two numbers whose product is negative 12, but who add up together, whose sum is positive 4. So I could have positive 6 and negative 2 are going to be the ones that work there. 6 times negative 2 is negative 12, and 6 plus negative 2 is positive 4. So positive 6 and negative 2. And similarly, if I do the trick, try and do the trick, which doesn't always work, but I can try it, two numbers that multiply together to give me positive 20, but add up together to give me negative 12. Well, I could have negative 4 and negative 5. That'd work in the product, but when I add them up, I get negative 9. How's about negative 10 and negative 2? That's going to do negative 10 times negative 2 is positive 20. Negative 10 plus negative 2 is negative 12. So now I have it completely factored out, and then to reduce this or write it in lowest form, I have a product in the numerator, a product in the denominator, and I can see that these terms are going to cancel. So this is my answer in reduced form. What if I try and do something like this? Again, before you start multiplying this times this and that times that, that's not how the procedure works here. You want to factor first. Always factor. Okay, you're going to get in a huge mess if you try and do multiply numerators and denominators first. Okay, so for this, two numbers that multiply together to give me negative 14, but add up together to give me negative 5. How about negative 7 and positive 2? What about here? Multiply together to give me 2, add up together to give me negative 3. Well, negative 2 and negative 1 should do. That's a difference of squares, so that factors. And two numbers that multiply together to give me positive 49, but add up together to give me negative 14. Well, negative 7 and negative 7. And now if I put these all together, I multiply the numerators and multiply the denominators, and we now have products in both. And so now I can look to see if I have any cancellation. And sure enough, I've got an x minus 7 and an x minus 7 there. I have an x minus 2 and an x minus 2 that will cancel. Will anything else cancel? I don't see anything else that will cancel. So I'm getting that for my answer. So I'll leave my answer in factored form. Sometimes some textbooks would then multiply these through, but I'm just going to leave it in factored form. Okay. Finally, what about this? Well, again, the key is factoring, and factor first. Always factor first. So this is pretty easy to do. Two numbers that multiply together to give me negative 12, but they add up together to give me negative 1. So negative 4 and positive 3. That is a difference of squares, but you know, if I swap the order there, then it's the negative. Now to see that, if I swap the order, just remember you have to take the negative, because that gives me negative 1, and that'll be 1 and negative 1. So how about I swap the order of that one? You'll see what I'm going to do with it in a minute. All right, what about this? Two numbers that multiply together 4, but add together will give me 5. Well, 4 and 1. 4 times 1 is 4, and 4 plus 1 is 5. Okay, and now here, I am going to have to try, because I can't use the trick on that one. Well, what are the factors of 2? I could have 2 and 1, or 1 times 2. Just do it like that. All right, but what about the factors for negative 3? I could have 1 times negative 3. I could have negative 1 and 3. I could have 3 times negative 1, and I could have negative 3 times 1. Now, I don't need to go through all of them. I just go through them until I find one that works. So I want outside plus inside to be negative 1. That's what we want. So outside is negative 6 plus inside is negative 5. So that's not going to work. Outside is 6 plus inside is positive 5. That's not going to work. Outside is negative 2 plus inside is 3, and that's going to give me positive 1. I want negative 1. So unfortunately for this one, I didn't get it till the very last one. Outside is 2 plus inside does give me negative 1. So this is the one that works. So, sorry, I'm going to have first and second factors. For my first factor, I'm going to use 2 and negative 3. And for the second factor, I'm going to use 1 and 1. So I should have 2x minus 3 for my first factor, and 1x plus 1. So that's how those work. Okay, I can check it quickly. That'd give me 2x squared plus 2x minus 3x minus 3, which is 2x squared minus x minus 3, which is what I have there. So 2x minus 3 times x plus 1. All right, now let's deal with this division sign. So the first stays the same. Then I change the operation to multiplication, and I flip the second term. Now to multiply these, I multiply numerator and denominator. Let's go ahead and multiply the denominator through. Now, what about this? Well, that's the negative of x squared minus 16, which is x plus 4 times x minus 4. So what I'm going to do, that's going to be the negative of x plus 4 times x minus 4. I'm going to multiply these together now, and I'm going to take the negative sign and put it out the front. Okay. And then I'm left with 2x minus 3 times x plus 1 times x plus 4 times x minus 4. Now everything's factored, and now I can do any cancellation if there is. I have an x plus 4 here and an x plus 4 there. I've got an x minus 4 there and an x minus 4 there. I've got an x plus 1 here and an x plus 1 there. And so my final answer is going to be this. And that ends the video.